Yesterday we took a look at the derivatives of transcendentals. Now we're going to look at applications and some of the same applications that we did last unit. So we're going to find a relative extrema of f of x equals x e to the x. Relative extrema, if you remember the relative max, min. All right. And how do we find those? Well, we need to find the first derivative. And it's when the first derivative equals 0. So when I go and do the first derivative, when I look at this, I see, oh, wait a minute, I've got two functions. So I'm going to have to use the product rule. Okay, I do x, and then derivative of e to the x is just e to the x, plus, then I do e to the x, and then derivative of x. All right, here, if I'm doing this without a calculator especially, I can factor out e to the x and left with x plus 1. And then I set each of the factors equal to 0. Now, let's recall this. E to the x. E is just a number. It's like 2 point something. Okay? And this says exponential. All right. Does this ever equal 0? No. So I'm not going to get an x value from there. But here, I get x equals negative 1. Now, I can figure out on the number or on a sign line, and I can put negative 1. I can see, is this positive or negative for the first derivative? If it goes from positive to negative, it's going to be a max. If it goes from negative to positive, it's going to be a min. All right, the other way we did it was through the second derivative. All right, so you can take the derivative at either point. You can take it here or you can take it here. I'm just going to do it up at the top. Here, you would have another product rule right here. But look, do you recognize this is the same thing as that? All right, so here, you could really just rewrite this, but I'll just do it again. Okay, I have x times the derivative of e to the x plus, now finish the product rule, e to the x, and the derivative of x is 1. Plus, the derivative of e to the x is e to the x. Well, here, this makes 2 e to the x. All right, now I can factor out e to the x, and I'm left with x plus 2. All right, and remember, you're trying to figure out at negative 1, is it a min or is it a max? All right, here, let's see, we want to find f double prime of negative 1. Okay, e to the negative 1, and then negative 1 plus 2. All right, whatever this is, it's 1 over e. Is this positive or negative? Well, it's positive. It's greater than. And remember, when the second derivative is greater than 0, then I have a relative min. So I have a relative min at x equals negative 1. Now again, I could take this and say the first derivative. All right, if I plug in something on the left side of negative 1, say negative 2. Well, negative 2, this is still positive. All right, negative 2, this is negative. So that's negative. All right, here on this side, say 0, e to the 0 is 1. Okay, 0 plus 1 is 1, so that's positive. And so think, it went negative to positive, so if I go down, then up, I have a min. Okay, so those are two different ways. However, if you do it this way, again, they don't grade this. So what you would have to explain is that it's decreasing on the interval from negative infinity to negative 1, and then it's increasing from negative 1 to infinity. Otherwise, this is enough to say why this is a min using that mathematical approach. Okay, let's look at this next one, finding points of inflection. Well, where do points of inflection come from? They come from the second derivative. And remember, the second derivative, you have to set equal to 0, but then also verify that there's a change in concavity. It either changes, the second derivative changes from positive to negative or negative to positive. It can't go positive, positive, or negative, negative. All right, so here we go. We're going to find the second derivative of this. So you got to stick with it. It's kind of ugly. All right, so first off, you got to find the first derivative. Now, all this out here is just a constant. Just leave it. Okay, the derivative of e to the negative x squared over 2. Okay, that's just e to the negative x squared over 2. And then you say times the derivative of this part. So that's negative 2x over 2. You'll notice the 2's cancel. And really what happens is, let's just clean it up. You get x over the square root of 2 pi, and then e to the negative x squared over 2. All right, now let's do this again. We're going to find the second derivative now. Now, again, this 1 over the square root of 2 pi, that's a constant. But I am going to have to do the product rule right here. Okay, so I'm going to have 1 over square root of 2 pi. Okay, I'm going to keep the x, and then I say derivative of this. That's e to the negative x squared over 2, and then times negative 2x over 2. All right, I'll clean up later. All right, plus, okay, now I still keep the 1 over square root of 2 pi, and then multiply it by e negative x squared over 2, and then times the derivative of x. Now, I've got to set this equal to 0, but let's clean this up. I can pull out the square root of 2 pi on each one of these. I can also pull out e to the negative x squared over 2. Now these 2's cancel. And I want you to realize there's a negative right here. So x, that's going to be a negative x squared. All right, and then that's just plus 1. All right, so here we go. Now, remember, second derivative equal to 0. Well, here, this part doesn't ever equal 0. Okay, so it never equals 0 because it's exponential. It's not going to cross the x-axis. So I really just have to look at x squared, negative x squared plus 1 equaling to 0. So 1 equals x squared, and then take the square root. All right, and I get x equals plus or minus 1. All right, now the question is, does it change concavity? All right. So here we go. On the left side of negative 1, all right, let's think about it. That's, say, negative 2. Well, this is always going to be positive. Okay, but if I plug in negative 2 here, that makes 4, but I have that's negative. So negative 4 plus 1, that's going to be a negative. Now, if I plug in 0, okay, I don't have to worry about any of that. That's always positive. Okay, 0 plus 1 is positive. And now anything after, say, positive 2, again, you only have to worry about this part. So that's 4, so negative 4 plus 1, that's going to be negative. And we notice it changes concavity. So I have points of inflection at x equals negative 1 and 1, because always explain why f double prime of x equals 0 and concavity changes from plus to minus or minus to plus, positive to negative or negative to positive. All right, moving right along. We want to locate relative extrema. All right, so basically relative max and mins. So we need to know when f prime of x equals 0. All right, so I'm going to find the derivative. So it's 1 over that right there, and then times 2x plus 2. All right, that's the derivative of what's inside. And I want to know when this equals 0. Well, here, if you recall, when I multiply by the denominator, it goes away, and I'm left with 2x plus 2 equals 0. When I solve this, x equals negative 1. Now, is this a relative max, or is this a relative min? Okay. Now, we can decide from the second derivative test. Okay, this will be justification. Now, I do have to do the quotient rule on this. All right, now, would that be difficult to do the quotient rule on? Yeah, and it's going to be kind of long. So let me show you the other way. If you just want to use a sign line, you just have to do a lot of explaining. Okay, when I plug in -1 into here, all right, I get, or not -1, when I plug in, say, something on the left, -2. All right, if I say f prime of -2, all right, so that's -2, that's -4, plus 2, which is -2. Okay, and then -2 squared is 4, plus 2 times -2, that makes it 0, plus 3. Okay, so this is less than 0. All right, and then if I do something on this side, say f prime of 0 makes it easy. Okay, that's going to be positive 2 over 3, so that's greater than 0. All right, so what I explain is that from -infinity to -1, f of x is increasing. From -1 to infinity, f of x is, and I said this wrong, this should be decreasing because it's negative, and f of x is increasing here because it's positive. All right, therefore, x equals -1, and think, negative, positive, down, up, is a relative min. All right, so here we go. So you can use the second derivative test, or you can use the sign line and use increasing and decreasing, okay, especially if it's a little harder to come up with the second derivative. All right, so here we go. Find extrema and points of inflection of. All right, so we want to find this right here. Now you may want to rewrite this so it's 1/2 e to the x plus e to the -x. All right, and remember in points of inflection we need the second derivative. So we got to first get the first derivative. Remember the 1/2, okay? The derivative of that is just going to be e to the x. Okay, derivative of this is going to be e to the -x, and then it's going to be times -1. All right, so this is 1/2 e to the x minus e to the -x. All right, the second derivative is not going to be much harder. Okay, here I'm still going to have that 1/2 out, but the derivative of e to the x is e to the x. The derivative of this is e to the -x times -1. So it really just takes us back. All right, now remember it's when the second derivative equals 0, but also changes concavity. So here, if I set this equal to 0, if I try multiplying by 2, it goes away. And I get e to the x plus e to the -x equals 0. All right, when I move this over, I get e to the x equals negative, and I'm going to make 1 over e to the x. All right, and here's the reason why. I'm going to create this like a proportion. And when I multiply these, remember, add your exponents, so e to the 2x equals -1. How do I get rid of e? Natural log. All right, can I do that? Does that happen? No, I can't have a negative beside of a log. So, therefore, no point of inflection. Now, I missed where it said extrema right here. So here we already know there's no point of inflection, but let's go back and find extrema. Extrema are when the first derivative equals 0. Okay, and when I multiply by 2, I'm left with e to the x minus e to the -x. All right, so if I add that over, it's e to the -x equals e to the x. So 1 over e to the x equals e to the x, and I'm going to treat this like a proportion again. So e to the 2x equals 1. All right, and how do I get rid of e? natural log. All right, here this makes 2x equals, and what's the natural log of 1? 0, and so I get x equals 0. And I just need to figure out, is this a max or a min? Well, by the second derivative, when I plug in 0, so if I go back to the second derivative of this right here, I get 1/2. E to the 0 is 1, plus e to the 0 is also 1. So this is going to be positive. So this is greater than 0. So when it's greater, we're going to have a relative min at x equals 0. All right, so two things going on. Okay, I have a relative min at x equals 0. Okay, and this time I did the first derivative, set it equal to 0, and then the second derivative, plugged that in. Since it was greater than 0, it's a relative min. All right, here I set the second derivative equal to 0. All right, but I came to a snag, and what that means is there's not going to be a point of inflection. Okay, let's find extrema and inflection points again. So we're kind of keep going with this. So if you want to, pause and see if you can do it with us. So the first derivative, all right, derivative of that, you can choose to multiply this through, or you can choose just to do the product rule. I'm going to do the product rule on this. Okay, so this is 2 plus x. Derivative of that is e to the negative x times negative 1 plus e to the negative x times 1. All right, what I can do is I want to know when this equals 0. So I'm going to pull out e to the negative x. And then if I multiply through by this by negative 1, I get negative 2 minus x. And then don't forget, you took this out, so I need a placeholder of 1. So this is e to the negative x times, that's going to be negative 1 minus x. All right, now set this equal to 0. Obviously, this never goes to 0, but I do negative 1 minus x equal to 0, and negative 1 equals x. All right, let's go find the second derivative. All right, second derivative of this, I'm just going to take it from here. Okay, e to the negative x times the derivative, which is negative 1. Okay, plus negative 1 minus x times e to the negative x times negative 1. Now, this negative 1 right here, I'm going to go ahead and distribute it through. Makes it a little bit easier. This is negative e to the negative x, all right, plus e to the negative x, plus x e to the negative x. Notice, these go away. All right, and for this, I want to find if this is a relative max or min. So I've got to take that second derivative, and I've got to plug in negative 1. So negative 1 e to the, it's going to be positive 1. Well, this is less than 0. If it's less, then I know I have a relative max at x equals negative 1. All right, now let's move on. And inflection point, that's when this is set equal to 0. All right, so when I set this equal to 0, remember e to the negative x never goes to 0. Okay, but that's when x equals 0. But you can't stop there and say it's an inflection point. You got to see if it changes concavity. So if I plug in negative 1, think about it. That's always positive. So if I just plug in any negative number, that's negative. If I plug in any positive number into the second derivative, it's positive. So the point of inflection is at x equals 0 because g double prime of x equals 0 and change of concavity. All right. Now, this problem, and this is going to be our last problem, and this is a little more difficult for this. Okay, if you start to notice, we want to find dy dx. So this is just going to be, that just looks ugly to do, find the derivative of. However, what we can do is we can use logs. We can do logarithmic differentiation. Okay. And what that's going to do for me is I can break this apart then. You may need some paper on this. All right. So what I'm going to do is I'm going to take the natural log of each side. Let me get a marker that works. ln of y equals, and I'm going to take the natural log of this side. All right. Now, remember, when it's complicated like this, we can expand. All right, so I'm going to keep this side as the ln of y for right now. Now, I'm going to expand ln of x minus 2 squared, and remember, that's going to be minus the natural log of, I'm going to go and make x squared plus 1 to the 1/2. Now, go do the power property. All right, so that's 2 ln of x minus 2. All right, now let's go take the derivative. Now this one, be careful. You got to take the derivative of the left and the right. The derivative of this is 1 over y. Okay, and then derivative of y with respect to x is dy dx. That's that implicit differentiation. Now this is a lot easier to take the derivative of because we still have that 2. However, the derivative of this is just over x minus 2. Okay, and then here I still have that 1/2, but the derivative of this is 1 over x squared plus 1. I would put it in parentheses. All right, the last thing I have to do to solve for dy is multiply each side by y. Now, do we know what y is? And some of you are probably trying to scrounge around and literally like, I don't know. Guess what? Don't we have y up here? So this is dy dx equals, all right, we're going to have 2 over x minus 2 minus 1 over 2 x squared plus 1. And then we times it by y, okay, which is x minus 2 squared over the square root of x squared plus 1. Now, you could get a common denominator if you want, and that would be fine. I'm just going to leave the answer like this. It does get a little complicated to do it, but if you ever have anything that's complicated, we can use logarithmic differentiation. Take the natural log of each side, break apart this natural log using your expansion rules. All right, and then we know easily what the derivative of the ln of something is. Actually, I did forget something right here. Can we go back? I forgot the derivative of the inside, which is 2x. So here, these 2's are actually going to cancel, and there should be an x up here. Sorry about that. Chain rule is something that is easily forgotten, especially if you're doing it quick. So be very careful. It is something that sometimes I forget too because I'm trying to do it fast. So please don't do that. And try to cross every T, dot every I.